Morning students. In this session we discuss about resistors are connected in parallel combination. In our previous class we discussed about what is meant by resistor and units of resistance and symbol of resistance. After that resistors are connected in a series combination. Now three resistors are connected in series combination. Those resistance R1, R2, R3 and effective resistance is simply R1 plus R2 plus R3. Now, in this session, we discuss about resistors are connected in parallel combination. Now, I take the three resistors R1 and R2 or R3. This is a resistor 1 of resistance R1. Second resistor, this resistance R2. Third resistor, this resistance is R3. Now, uh, connect the resistor in parallel by joining their one ends connected to positive terminal of the battery or one terminal of the battery, and other ends, these are the second ends, other ends connected to a negative terminal of the battery or another terminal of the battery. This combination is known as parallel combination. Once again, connect the resistors in parallel by joining their one ends, one terminal of the battery, and another terminal of the battery. This combination is known as parallel combination. The battery of EMF or voltage is V. Battery voltage A. Observe the students in parallel combination. uh, potential difference exists across the all potential difference or same potential difference exists across all resistors. In parallel combination, potential difference same, but current is divided. Current is divided. Suppose in the circuit I current is drawn and current is moving like this, positive terminal to negative terminal. At the junction A, the current is divided into three parts: R1 resistance, in the R1 resistance, in the R2 resistance, in the R3 resistance. That is, we assume I1 current is possible, I2 and I3. The total amount of current I is divided into three parts: I1 and I2 and I3. Now, according to Ohm's law, V equal to IR, then I equal to V by R. I equal to V by I. Now, potential difference across the each resistor is same. Across the R1 resistance is V, across the R2 resistor is V, across the R3 resistors also V. Now we write the amount of current across the first resistance is I1 equal to V by R1 because of V is constant, and second amount of current V by R2, and I3 equal to V by R3. Observe, in the three situations V is same because of whenever the resistors are connected in parallel combination, same potential difference exists across the all resistor, but the amount of current into divide. Now then I equal to total amount of current equal to I1 plus I2 plus I3. Now we write the I equal to V by R. Here I1 equal to V by R1. Here V by R2. Here V by R3. Now we write in these three terms V is common, 1 by R1 plus 1 by R2 plus 1 by R3. Then V get cancelled. The effective resistance of resistors connected in parallel, that is R1 plus R2 plus R3. I take only 3 resistors. That's why 1 by R1 plus 1 by R2 plus 1 by R3. Suppose we take the 4 resistance plus 1 by R4. Suppose we take the 6 resistance 1 by R4 plus 1 by R5 plus 1 by R6. Now n resistors of resistance R1, R2, R3 up to so on Rn. These are connected in parallel combination. The effective resistance is 1 R effective or 1 by R parallel. It is same 1 by R1 plus 1 by R2 plus 1 by R3 plus up to so on plus 1 by Rn. Now, two resistors R1 and R2 connected in parallel combination, then effective resistance is 1 by R effective equal to for only two resistors 1 by R1 plus 1 by R2. Then we get R effective equal to R1 R2 by R1 plus R2. How is it possible? Observe the students. Here R2 plus R1 by R1 R2. This is the 1 by R effective. Now we take the reciprocal. R effective equal to R1 R2 by R1 plus R2. So the final effective resistance when our two resistors are connected in parallel combination R1 R2 by R1 plus R2. Thank you for the watching.